What's going on, everybody? There's one more additional spreadsheet that I want you to create here on your set of tools, and it's going to help you work with these normal distributions as well as the t-distribution to do some very quick calculations that will help you out not only on assignments, quizzes, and tests, but even as we're going through some things in class. Fortunately, it doesn't take a whole lot of time to create, so I think this will be pretty quick here. So what I'd like to do is to pull you back to your spreadsheet here. The additional sheet that I want you to create is called Z and T scores. Z and T scores. So make that the name of the tab that you're creating on this here. And let's start this off here. I've got my cursor up in A1, and I'm going to type Z scores in A1 here, and I'm going to tab over to column G here because I'm going to have some more over here for the T distribution here. So this is going to be T scores like this. And I'm going to zoom out a little bit here, back to 100% here so it's a little easier to see. I'm going to make everything in this row here boldface as well as 18-point font. So we've really got two sections here that we're generating for this. I'm going to come back over here to column B, row 3, and I'm going to type enter z-score for this. And I think I'll just put a number 0 in here for our z-score. This is going to be an input field, and so just as usual, we're going to color that green. I'm going to go to the right a little bit here, a couple of columns where we're going to give some output data. It's going to have two columns to the output data here. The first one is going to be for probability z being less than z. So in other words, what's the probability that that you're going to have a value of the normal distribution that's to the left of the one that you're giving here. The one next door to it is going to be for the probability that z is greater than big Z. So this is little z and this is big Z here. And then along this column here in column C, in this spot, I'm going to put one tail and then two tails here. And let's see, let's go down. Let's see, one right here, and let's put our cursor in B7 here, and I'm going to type enter P score. And for this one, I'm going to put an example of 0.5. This is our input field here for this. It's another input field, so we're going to call this green. And then to the right, let's go two columns over here, and this is going to be for z-score right in here. And since this is an output field here, I'm going to surround it by borders, make it look nice there. And then I'm going to actually do the same thing here for these four spots, surround those with borders as well. Okay, and then I also want to boldface all these titles here. So I'll boldface that, boldface that, boldface these, boldface this, and I'll boldface this as well. And for these two, I'll also right justify them so that they're hanging out real close to this. All right, that's half of it. The other half is going to be virtually identical to it. It's going to be over here in the t-scores area. And so I'm going to put my cursor here in H3, and I'm going to type enter t-score and DF. DF stands for degrees of freedom. You'll understand that more as we get more into the t distribution here. So we've got on the left-hand side here, this is going to be t-score and DF for degrees of freedom here. And let's just put in some example values here. I can put in 0 for the t-score and maybe 10 for the degrees of freedom here. We can also go down a little bit more here to row 7. So this is H7, and I can type enter P and DF, probability and degrees of freedom here. So this is now going to be a p-score as well as degrees of freedom here. And so for this, I can say 0.5, and I think I'll put 10 here as well. Now, just like for the z-scores here, these are input values, and so I'm going to color these green here and color these green as well. And again, I'm going to boldface this, boldface this, boldface these, and boldface these, and then right justify both of those, both sets. All right, so that's the input for the t-score. Let me indicate what the output should be here. It's actually going to be pretty much the same thing that we had before here on the left. So I'm going to type for probability of having a score on the t-distribution that's less than the one that's given to the left. So probability of t being less than t for the first one. You can probably guess what the second one's going to be. Probability that t is greater than t. So little t is greater than big T here. All right, and then on the left-hand side here, I'm going to put one tail and two tails again. Whoops, two tails. And I'm going to boldface all of that. And I'm going to right justify this. And this is going to be a place where I put some output, so I'm going to format it similar to what I have over here. Give it some borders. And then underneath this, I've given it a probability and a degrees of freedom here, and here I'm wanting to calculate a t-statistic. So this is for t-score right here, and I'm going to put some boundaries around this and make that boldface. Okay, now I just have to fill in the formulas for all of these things here. Let's take a look at the stuff to the left here. Let's do the bottom ones here first. Those are actually a little easier. So for this bottom one right here, for z-score, what we want to do is type in a formula. This is going to be equals norm INV. That's the inverse normal distribution function here. So I'll enlarge this in just a moment so you can see the function a little bit easier here. But it's got three parameters to it. The first one is going to be this p-score right here, and the second one is going to be 0, and the third one's going to be 1. Okay, so let me see if I can hit enter on that. Now I'm going to zoom. Actually, it'll be nice. There we go. So if I zoom in here, now you can see that formula pretty clearly, I think. So norm INV, first parameter is here, B8. Second parameter is 0. Third parameter is 1. So in other words, where is the median value for a normal distribution that has a mean of 0 and a standard deviation of 1? And the answer is that it should be 0. Okay, so let's scroll to the right here. Let's basically do the same thing or something very similar here for the t-score. The formula for this is actually a little simpler. It's calling for the same kind of thing, but for the t-distribution, this is t dot INV. This is the inverse t distribution. And this has got two parameters here. One is the probability that you've put here. The second is the degrees of freedom, which you've put here. So that's what our formula looks like for this. And so once again, this is asking what should the t-value be for the 50th percentile for a t-distribution that has degrees of freedom of 10. And for the 50th percentile, no matter what degrees of freedom you've got here, the answer is going to be a value of 0 here. It's right in the center of the distribution. Okay, so now let's take advantage of filling in these four in the upper left here. We're back to the z distribution here, and let's see what those values should be here. So for the first one, I'm going to click in the upper left-hand corner here. So under one tail for the probability that little z is less than big Z, here's our first formula. Equals norm.dist. So the normal distribution here, you might recall using this when we were working with the creating your normal distribution um, tab for your spreadsheet. We have four parameters to this. The first one is this value right here, B4. And the second one is that we're dealing with a normal distribution with a mean of 0, a standard deviation of 1, and yes, we want it to be cumulative, so this part here is true. So that is the formula there for the upper left-hand corner here. Norm dist B401 true. The one to the right is actually even easier. It's just equals 1 minus this. These two probabilities have to add up to 1. And so if this is equal to something, I can just find out what this is by taking 1 and subtracting this one. So this is just 1 minus d4 here, which when I hit enter is 0.5. Okay, I'm going to scroll to the right here once again because we'll do something very similar here for the t-distribution. This function here is t-dist, t.dist. It's got three parameters to it. The first one here is this 0. The second one is this value 10 here. So, excuse me, the t-distribution, the t-score, the degrees of freedom. And then again, we want it to be cumulative, so the answer to the third one is true in all caps. So that's our formula there for the upper left. And then for the upper right, we're going to do the same thing as before. This is just going to be 1 minus whatever this is. So this will be, that not work? 1 minus this. So 1 minus J4. So that should also be 0.5 here. Okay, now let's go to the left here, back to z-scores. And let's take a look at these values here in the lower left. These are a little bit, the formula is a little bit more complex here, but nothing compared to some of the things you've had to deal with previously. This one basically has to choose the smaller of the two values up here and then double it. It's essentially what it has to do. So for the two tails here, it's going to be a value of that begins with the word if. All right, so if d4 here is less than 0.5, in other words, if it's the smaller of the two values, then what you want to do is double this. So 2 times d4. And if it's not, then this is going to take a passive roll to the other side. So it's going to be 1 minus 2 times e4. Okay, so that, I realize that looks a little weird here, but I'll leave that up for a little bit so you can see that. So if this one is less than 0.5, then double it. And if not, then go with this formula here. So doubling of this subtracted from 1. So 1 minus 2 times e4. Okay, the other formulas from here on out are going to be virtually identical to that, so the same type of thing here. This is going to be another if function here, so equals if. This time we're looking at whether or not e4 is less than 0.5. And if it is, then double that, 2 times e4. And if not, then you'll make this equal to 1 minus the other one. 1 minus the double of the other one, rather. So 1 minus 2 times d4. And parentheses. So there we are again for this one. Okay. And now for this one here, it's actually pretty much the same idea here, same thing. So for this one, it's going to be another if statement. If equals if. whether or not this is less than 0.5. And if it is, then double it, multiply it by 2. And if not, then subtract from 1 the double of the other one. Okay. And then lastly here, same type of thing. So this is going to be if this is less than 0.5, and if it is, then double this. And if not, then subtract from 1 the double of the other one. And there it is there. Okay, so hopefully that's helpful here. Let me zoom out a bit so you can see how you'll be working with this. You'll actually be working with this quite a lot. This will be probably one of the more heavily used sheets in your spreadsheet. So keep that in mind as you're working with this here, that you're actually creating probably one of the most useful spreadsheets for the whole course here. Here's how you're going to be using it. Let me see if I can pull this up here. So yeah, if you want to put in a z-score here, you can find out how much area is to the left of that position, how much area is to the right of that position. And that's really useful here. Here you're doing the opposite. You're giving it an amount of area, and you're wanting to find out what the z value would have to be in order to correspond to this percentile right in here. So if I'm taking a look at 0, then yeah, right at 0, half and half. The area of the shape of the normal distribution is symmetric, and so half the area is on one side, the other half is on the other. But if I put this as a z-value of 1, now we have 84% of the area that is to the left, with the remaining 16% to the right of this. So we've moved this to the right just a little bit, and so now 84% of the area is here, leaving just 16% of the area over here. And if I go out a little farther, now it's about 97.7% of the area that is to the left of this, with only about 2.5% of the area to the right of it. I can also go in the opposite direction with negative numbers, and really the numbers just reverse here, don't they? Because of the symmetry of the normal distribution here. So if I'm moving to the left, now the 84% is on this side and the 16% is on this side. And if I go to -2, again, we've got the 2.5% over here and the 97.5% on this side. Okay, so essentially these two parts here, top and bottom, are the opposite of one another. Here I put in a z-score and I get a probability to the left. Here I put in a probability to the left and I get a z-score. Okay, so for example, if I put in 0.02275 into this, so 0.02275, this should give me -2 for the answer here, or something close to it. Let's see if it does. Yeah, it does. So -2.000002444. All right, so just illustrates here that this is the opposite of this. Okay, so you're entering a z-score here and getting probabilities. Here you're entering probabilities and getting a z-score. All right, and the t-score side acts the exact same way. You're just using a t-distribution, which means that you not only put in a t-score, you also put in degrees of freedom. That's just another parameter that you have to put in for the t-distribution here. But in the same way, if I put in one standard a t-value of 1 here, the numbers are close, but they're slightly different from what you have for the normal distribution. Now it's 83% of the area that's to the left, with 17% of that area being to the right now. And of course, if I go negative, then these things just reverse here. Now it's 17% on this side and 83% on the other here. So, and with that in mind here, 0.170446. I think what I'll do is I'll put that here, 17044 65662. Let's do the whole thing here. I should get -1 for my t value here. Let's see if I get that. Yeah, very, very close. -0.999999998. So very, very close to that. So just illustrating once again that these two things, top and bottom, are inverses of one another. And that will come in handy because sometimes we're wanting to find probabilities from z or t values, and sometimes we're wanting to take z or t values and get probabilities out of them. And that'll become more clear as we work with these things a little bit more. So hopefully that is helpful to all of you. I think that's the last thing that we'll need to do here in order to complete out project 3.